digital information is ontologically neutral. What this means is that binary code can indifferently represent text, sound, images, or video. As usual, the development of generative practices trickles up the dimensionality gradient. One-dimensional media, such as text and sound, were the first to draw the attention of generative practices. Two-dimensional media, such as images, were explored next. Three-dimensional media, such as culture, architecture, and morphological models, found some application next. And four-dimensional models, such as animation, film, video, or virtual reality, have been the last category of media to see successful generative practices. Consequently, the area of moving images has received less attention than other media. There is nonetheless a history of generative explorations in the domain of moving images. In this lesson, we present a selection of artistic and research works in generative systems for moving images, with an emphasis on those that use raster images. Lynn Hirschman-Leeson's piece, Deep Contact, from 1984, is an interactive video disc installation that uses a touch-sensitive monitor. The user is detected with a surveillance camera, which prompts a female character to invite the user to begin the interaction. The user then triggers one of various storylines by touching a part of the character's body. This is not a generative piece per se, but it is certainly interactive and nonlinear. In interactive art, the author does not give autonomy to the piece itself, but to the audience. The user is left navigating the nonlinear structure of the piece. For digitally generated renderings, French artist Michel Bret applied chaos theory and self-replication to animated films. In 1988 already, he invented the automapping techniques, which consist of recursively mapping animations onto themselves. Bret develops his own software to manipulate animations. The AnyFlow software is written in C and rendered on Silicon Graphics machines from the 80s. Automap from 1988 is the main film produced using this technique. Let's watch a short excerpt of this film. At the turn of the millennium, artist and media art theorist Lev Manovich developed a new vision of cinema in the digital era. As a theorist, he explicitated the 5 principles of new media. The first principle is encoding. All new media objects are made of data, made of zeros and ones. The second principle is transcoding. The same content can be coded in different media. The third principle is variability. Multiple versions are cheap and can be edited easily. The fourth principle is modularity. Systems are made of modules and can themselves serve as modules. And the fifth principle is automation. New media objects can be created automatically. These principles are exemplified in the piece Soft Cinema. The 2003 piece generates an infinite narration by selecting shots from a database and articulating various symbolic and sub-symbolic features: camera movements, contrast, distance to camera, name of the shooting place, description of action, etc. The shots and sounds selected are edited in real time in a collage that follows the rules programmed by the author in this early example of database cinema. In database-based cinema, generative systems deal with video shots and raster images from a database of shots. The typical procedure for video editing involves many creative tasks. These include storyboarding and preparation, selecting the shots themselves, sequencing the shot, selecting the cutting points, camera controls such as zooming and reframing, and transition effects between shots. And then finally, there is the soundtrack composition that also deserves attention. Some or all of these steps have been automated to produce films in a variety of genres. We find examples of video summaries, movie trailers, documentaries, stage performance documentation, ambient video, video mashup and resynthesis, music video, experimental film, video installation, etc. We will look at a few examples starting with some of the most functional and generic systems from computational creativity to more artistic explorations. With the democratization of video recording equipment, there is a proliferation of video content. Video summary has attracted a lot of attention since the end of the 90s. Hitchcock from 2000 is a computer-assisted editing system for home videos. It analyzes shots to determine the type and amount of camera motion and the level of brightness. It then filters out moments with erratic camera movements, which are typical in video shots with handheld device operated by amateurs. It also eliminates very poorly lit or contrasted shots. Once the system has selected a set of recommended clips, the user still has to sequence them and decide the length of each clip. For a given length, Hitchcock will set the in and out point of each clip automatically. A particular type of movie summary is the movie trailer genre. While video summary tools focus on image quality and notable events, movie trailers have attracted research on viewers' emotion and attention. The trailer generation system proposed by Xu and colleagues uses a model to predict the attractiveness of the shots in the sense of their capacity to retain the viewer's attention. The machine learning system is trained with data gathered during a perceptual experiment that correlated attractiveness with the quantity of movements in people's gaze. The idea is that if people do not move their eyes away from a particular place in the picture, it is because they are captivated. A saliency curve is extracted from the music as well. Shots are selected based on duration, camera movement, and degrees of brightness. Here is an excerpt of a trailer generated by the system. Gandhi and Ronfa in 2015 proposed a tool for vertical editing in stage performance documentation. Vertical video editing is the process of digitally editing the image within the frame, whereas horizontal editing is that of arranging shots along a timeline. Vertical editing can be a time-consuming and error-prone process. Using practices from traditional cinematography, the tool acts as a virtual camera assistant to the film editor, creating a set of plausible shots for every input video files. The tool computes virtual pan, tilt, zoom, and camera movements, and it can recognize and frame the actors. Another genre that has been looked at is documentary. Vox Populi is a 2005 system that generates documentary video sequences. The input for the system is shots of people talking that are manually labeled with rhetorical annotation, such as the claims and the argumentation moves the video content contains. The system then assembles these into sequences that build a convincing argument towards a goal. It uses a semantic graph together with the formal argumentation model from Stephen Toulmin. On the artistic side, ambient video is a genre that is adequate for exploring with generativity. Canadian videoist and researcher Jim Bizocchi defines ambient video around 3 attributes. It is visually rewarding at any given moment, it does not require sustained attention, but it is visually interesting even with direct attention and repeated viewing. Season is an ambient piece from 2014 by Bizocchi, Engelfeld, Thorogood, Fan, and myself that combines 3 systems. The first system is the Recycle system by Jim Bizocchi that provides the video shot sequencing and transition engine. The engine decides on a season and selects and sequences shots accordingly. Each shot's content is described with a series of tags. The second system in action in Season is Audio Metaphor, a soundscape generation engine that takes a series of keywords, in this case the tags assigned by the recycled system to the shots, as well as the perceived valence and arousal of various sounds to generate a soundscape that matches these. The third system is the MuseBot system. Musical agents also receive from the recycled system tags and listen to the soundscape, and they can add music when deemed necessary. Here is an excerpt of the piece itself. YouTube's Mashup is a 2013 automatic mashup system by Parag Mittal, who is also the instructor of the creative application of deep learning with TensorFlow class at Cadence. The system is a video resynthesis system that uses the top 10 YouTube videos at any given time. It resynthesizes the number 1 video solely using the material from the remaining 9 videos. The process, called Smashup, is a new kind of remixing or mosaicing process. It learns very small fragments of the audio and video and recombines them to construct the target video. The underlying corpus-based visual synthesis system analyzes both the corpus and the target by breaking each frame into shapes and consistent regions. Each form, shape, or region in the target image is then replaced by the nearest one from the corpus. This work attempts to focus on how copyright laws will treat these kinds of work in the future when the computational tool we use to remix media are able to understand content in a deeper way than just by processing its textual metadata. Here is an example of Smashup for which the target video was the famous K-pop hit Gangnam Style. DG MVP is a 2015 system by Jian Yufan and myself that automatically generates audio-video mashups. MVP stands for Music Video Producer. Since a lot of the systems in our lab produce electronic dance music, we thought it would be good to have a system that generates video clips for these tracks. A large corpus of existing music video is first segmented according to the rhythmic structure of the tracks. The idea is that the images should match the sounds in these music videos very well. Then, each audio segment or target track is mapped to an audio-video segment from the database. Some heuristics are used to avoid repeating a given segment too often and to ensure color and brightness coherence between shots. The video segments retrieved are concatenated and a data moshing effect is added. Here is an example of a video by DG MVP. Generative methods give rise to new forms, and some are following the steps of Lev Manovich's database cinema in a genre that could be called experimental algorithmic cinema. Douglas Stanley, an American artist based in France, is an advocate of algorithmic cinema. His system, Concrescence, from 2006, puts these ideas into practice. It is a sophisticated interactive system in which the user chooses shots from a library and trains the system regarding the relationship between shots. A simple generative system based on artificial life generates new sequences with emergent narrative relations and forms. If the system is not used, it will start taking initiative and generating new sequences using a predefined ambient generative setting. Let's watch a short excerpt of a video presenting the system. In Century, from 2013, Mulgeert, a media artist, generates visual poetry by assembling images that he collects from databases of video, photographs, and installations. Generative systems are also used in video installations. It is a way to avoid any repetition and explore vast quantities of content. Longing and Forgetting is a generative video piece by Tekla Schifort, Matthew Giegold, and myself. It consists of a collection of video agents. A video agent plans sequences of movements by sequencing video clips that they need to play to get from one place to another. Presented in gallery settings or as a facade projection piece, the video agents occupy the architectural space that they're projected on. Here is an excerpt of the piece being projected at the Urban Screen venue in Surrey, Canada, as a public art presentation. Of course, with this technique, we can easily multiply the number of agents and manipulate their goals to get complex choreography from which big structures can emerge. This concludes our survey of current advances in generative moving images. Moving images are still the costliest medium to process in terms of computation and memory, and this medium has not yet received the attention that other media have throughout the years. As we make progress with images, which video is made of, new media and new resolutions are appearing as well. Three-dimensional videos is well implanted, and virtual reality is expanding quickly. The challenges regarding these new formats and how to best generate content for them are yet to be addressed.